Okay, so in short review from yesterday, you guys drew several images to depict what you thought of when you thought of an atom. And some of the things that I saw in the drawings were really good in as far as kind of recalling different areas of the atom. And the thing that we need to work on now is actually getting those terms to put together and getting all those little particles that make up an atom in the right spot. So who could recall what I said yesterday was that center region of an atom? Logan?
The nucleus.
The nucleus. So the center region is going to be called the nucleus. And then what did we say was located inside the nucleus? Okay.
Protons.
Protons. So one of the particles inside of a nucleus would be called a proton. How many protons do you think there are inside of a nucleus? Landon?
I'm just making a guess.
Okay.
I say about like 3.
About 3. Okay. Anyone have any other ideas? Okay.
8.
8?
10.
10? Braden?
5.
5? I think I said I. Sorry. 5?
6.
6? One more guess. Anyone else have a really... I'm pretty sure of this guess. Ella?
Maybe like 7.
7. Okay. We also said in the middle, and we're going to come back to that, so just hang tight on that one. We also said in the middle we had what other particles? We had protons and, go for it, Autumn. Neutrons. Good. So the other one we have is neutrons. And then we said around the outside, we had some particles that were in motion, meaning they were moving all the time. What did we call those particles? Ethan? Electrons. So the electrons are actually the smallest, and they're in motion. So if you want to draw an arrow along those lines, you could draw an arrow saying that they tend to be found around the outside. They also tend to move in very predictable patterns. So with electrons, depending on how many electrons that atom has, they have very predictable patterns. So this would be an electron. With the area that it moves along, so some of those paths, I'm going to draw one, like a path like this. We could call that an electron orbital. Or often we call this area an electron cloud. So it's like a space or an area in which those electrons are commonly found around the outside of a nucleus. Okay, so a lot of terms. What about the number of electrons that you would find in an atom? What do you guys think?
I'm guessing about 5.
5? Okay. Ethan?
30.
30?
25.
Do you guys think it's a specific number for every atom?
No.
Okay, so if it's not a specific number for every atom, what do you think? I want you to talk about that at your tables right now. Okay, so it depends on how big the atom is. What do you mean by that?
Like, the nucleus is.
Okay. So if you think of a nucleus is bigger, then you have more electrons? Okay. Other thoughts that you guys discussed in your small groups?
About 20.
You just think it's about 20. Okay. Ella?
We just kind of think between 15 and 30-ish.
Okay. Okay, good. Okay, so again, we're going to answer that question. We're going to talk about that here in a little bit. But the last thing I want to clarify for you guys is the electron orbital, or that area that an electron orbits around the outside of a nucleus, the shape it orbits changes as well. So it's not always a circle. But quite often, how many of you have seen a drawing similar to this before for an atom? We have them often drawn this way to make it easier for us to understand exactly where things are located. The big take-home message for you guys at this point would be to know that the center region is a nucleus. Inside that center region, you have particles that are called neutrons. You have particles that are called protons. And then the part of the atom itself that's in motion is that part that goes around the outside, and that's the electrons. So here's how we're going to go about answering your question about how many electrons or how many protons is in an atom. Anyone have any idea what this image is? Landon?
Part of the periodic table.
part of the periodic table. Great start. Okay, what else do we know? Ethan?
An element for the periodic.
It's an element for the periodic table. So at your tables, what's the difference between an element and an atom? Go. So what did you guys come up with? What's the difference between an atom and an element? Sloan, you want to share? Go ahead. What'd you guys talk about? What'd you come up with, the Sloan? What'd you guys talk about?
Well, an atom has like protons and neutrons and stuff.
Okay, and an element. So you said an atom has protons and neutrons and stuff, as opposed to an element that would have what?
You're not sure about that.
Not sure. Okay, Bailey.
An element and protons and are all together. That
Okay, so in an element, the protons and neutrons are all together to make it an atom. Is that what you just said?
kind of.
Okay, other thoughts, Ethan?
An atom is an element.
An atom is an element. Okay. Logan.
An element is one single kind of substance, and the atom has the nucleus, protons, and neutrons, protons, and electrons.
Okay, so you think an element's a part of an atom? Is that what you're saying?
Yeah.
Okay. So here's the big difference. And on your sheet of paper, you see where it says an element. Here's your definition for an element. It's a substance that cannot be broken down. So that says broken down into another substance by chemical, so by chemical or physical means. In other words, it's the simplest particle that we're going to get down to. The difference between an atom and an element would be like the difference between an ice cream store with all these different types of ice cream and chocolate ice cream. Okay? So the example, it would be that if you walk into an ice cream store and they have 10 different flavors of ice cream, those are elements. But if you get chocolate, that's an atom. It's like a specific kind. Okay? So they are the same in a sense. I think Ethan's response is probably the closest. There's not a lot of difference between them. When we talk about the periodic table, we're talking about the periodic table of elements. And on that periodic table, there are individual types of atoms. So, for example, this type of atom, or this element, is carbon. And so what we need to know is, why is it that our periodic table is arranged the way it is? And what is it that our periodic table tells us about every single element? So when we talked earlier about you guys making a guess about how many electrons, how many protons, how many neutrons was in something, here's how you can know for sure. When you look at this, the big C is what we call the atomic symbol. Sure can. I would certainly get this in your notes. This is something you'll see on your quiz next week. So the big letter is the atomic symbol. Sometimes there are two letters, like 10 is SN. Okay? So sometimes they can be more than one letter. They're never more than two letters, though. The next part where it says carbon, that's just the name. Pretty simple. The atomic name. Now there's two numbers up here. There's a 6 up here, and there's a 12.01 for carbon. Okay? That 12.01 is what we call the atomic mass. And on the other hand, that number at the top, the 6, is what we call the atomic number. they tell us something very important. They each tell us something very important. The number at the top is going to tell us how many electrons we have in that atom. The number of electrons is also going to equal the number of protons. So it's going to tell us how many electrons are around the outside and how many protons are on the inside. So what Dane was saying, and a couple of you said this, as it gets bigger, you're going to have more electrons. And in a sense, that's right. Because your nucleus is going to get bigger, when you add more protons, correct? It's kind of like a mesh bag holding 6 balloons. Then all of a sudden a mesh bag holding 12 balloons. Which mesh bag is bigger? The one with 12 balloons, right? So as the nucleus gets larger, meaning it has more particles, more protons, more neutrons, you get more electrons. So I would put a side note down here that this is going to tell you the number of electrons and when we talk about the word mass, we need to figure out what we mean by that. So when you finish writing down the number of electrons for that atomic number, I need you to talk at your table. What do we mean by the word mass? What is mass? Jaden.
Mass is like how big something is.
Okay. Mass is how big something is. Landon?
Mass is weight.
Weight. Okay. Paige?
Anything that takes up space.
Okay. Anything that takes up space. Okay. So to be really clear, how many of you have ever heard of gravity? Does anyone know anything about the gravity on the moon? Yeah.
It's hardly any.
Yeah, it's a lot less than the gravity on Earth. When we travel to the moon, do you have less mass or more mass?
Less. Wait, more.
What if I tell you that the mass is just all the stuff that you're made of?
Less.
Do you get more or less when you go to the moon?
More.
Or is it a trick question?
It's a trick question.
Why is it a trick question?
I don't know.
Mass is everything you're made of. You go to the moon. It's all the stuff in your body. It's all the same. Your mass will remain the same on Earth as it will on the moon. Good job, Jessica. Because you don't lose part of your body. You don't lose like an arm before you go to the moon. I mean, I would hope not, right? On the other hand, Landon used the word, somebody used the word your weight. I don't remember who. Your weight, however, changes from Earth to the moon. Because your weight is actually the measure of how much gravity is pulling you down. You stand on a scale, right? And the only reason you can stand on that scale is because Earth has gravity and it pulls you down. If you go to the moon and you stand on your scale, you're going to weigh a lot less. It's a great diet plan. Long travel distance, however. So keep in mind that your mass is everything you're made of. Your weight is what is the measure of gravity pulling you down. Okay? So if we're talking about mass being everything you're made of, what do you think the atomic mass is? So go ahead and talk at your tables for a second.
Is what the atom is made of.
Good. So the atomic mass is what the atom is made of. So in this case, carbon, it's a whole mass, everything it's made of. What do we say that atoms are made of? There's 3 parts.
Protons, neutrons, and electrons.
Good. Protons, neutrons, and electrons. So the atomic mass is the measure of all of that stuff together. Okay? If we wanted to figure out how many neutrons we have, we can do a little math problem. Raise your hand if you're good at math. Awesome. So there's somebody at each table. All we have to do to figure out the number of neutrons, we know how to find the number of electrons, right, Dane? How do we find that?
You look up there.
At what?
The 6.
The 6, which is called the atomic number. And on the other hand, we want to figure out the number of neutrons. We're going to take this number and we're going to round it to a whole number. Raise your hand if you've ever heard of rounding to a whole number. Autumn, your hand is up. If we're rounding 12.01 to a whole number, what would we round it to? 12. Awesome. Right? So it's 12. And then we're going to subtract off the number of electrons we have. Jessica, how many electrons do I have in carbon?
12.
Number of electrons?
Oh, electron, 6.
There you go. 6. So we have 12 minus 6, and we get what,
Yeah.
Maggie?
6.
6 neutrons. So again, to be very clear, we took 12, we rounded it to a whole number, and then we subtracted 6. What's the name of that number for an element, Jaden? The atomic number. So we subtracted the atomic number from here. And then we could figure out how many neutrons was in that single atom of carbon. It changes. For every different type of element or every atom, there's a different number of electrons, protons, and neutrons. So the periodic table itself is arranged in such a way that it's common properties, meaning in an order so that it's increasing in electrons. It's in an order so that anything that has similarities like metals or non-metals are kind of grouped together. But it's really fascinating when we start digging into this how perfectly arranged this periodic table is. Okay, so we're going to do an activity with that, and then we'll get back into small groups for that.